Before we develop version number 2, the ultimate solution, I would like to introduce to you the syntax and semantics for two-dimensional arrays, which are pretty similar to the syntax and semantics for one-dimensional array. You can think about it's more like a generalization in terms of understanding. Let's try that, and then we'll annotate as we go. Let's now right-click on the console apps package, and then let's create a new console application class. Let's call that maybe two-dimensional array app. Two-dimensional array app. And make sure you choose the main method and finish. Okay, and let's now try to do introduce the syntax first. Before we see the syntax for two-dimensional arrays, let's recall what the syntax is like when you declare and initialize a one-dimensional array. So we'll see the relationship. So this is how we declare some one-dimensional array. So you can see the square brackets over here is saying it is an array. And every slot of the array will actually store simply an integer. And remember, it's homogeneous, meaning that you cannot simply get a mix of the element type. It has to be a homogeneous type. It must be the same type. Okay, let's say list is assigned to, and we can use the initializer expression. There are two ways for us to initialize an array. We can either say it's assigned to new using the new keyword, and then we can assign individually to the elements in the array. That's something we'll see later. But let's now see the easier one, the more intuitive one, which is to use the initializer expression. So we will say curly brackets over here, and of course this will just be valid just like an empty array. But if we want to actually have some non-empty array, we'll use a comma separated list, and every member in the list is going to match the type of the elements in the array, which is integer. Let's say this. For example, I can say 1, 2, 3, and 4 over here. So this is one list over here, right? That's pretty easy. And one more thing to note. You can see the single occurrence of the empty square brackets here specifies the dimension of the array data type that we are trying to declare for the variable. So if there's only one single occurrence, that's only a single dimension of the array. And then for that single dimension of the array, every slot in the array is going to be integer. So now how can we increase the number of dimensions for our data type? So what we can do is simply just add another instance of the square brackets. So this will be one dimension. This will be another dimension. Okay, so far what have we specified? We are saying that the first dimension of the array, every slot of the array is going to store another array. Okay, and then that particular second dimension of the array, every slot of that second dimension array is going to store some type that we're going to specify, integer over here. Of course, the number of square brackets you want to really have to really increase the dimension is kind of unbounded. It's really up to what you need for your application. But I would say for this course, we'll only go up to the 2 dimensions for you in the tutorial videos. But beyond this course, you can feel free to explore about multi-dimensions of the array. It's definitely possible. Let me say that again. The way to read this declaration is like this. So this will be the first dimension, like pretty much like a rows of your table. And this will be the second dimension over here, pretty much like a column of your table. And then the way to read about the types for each dimension of the array will be, this will be the first dimension of the array. Every slot of the first dimension, every slot in the first dimension of the array is going to store just another array. So that'll be the second dimension. And each second dimension array in their slot, they're going to store an integer. So if you can somehow visualize what I have just spoken about, it will be good for you. Otherwise, I'm going to visualize together with you in just a moment. Let me finish the syntax. Let's declare the variable name. Let's say list2. 2 standing for 2 dimensions. Okay, it's initialized to be, and we can also use the initializer expression. Let's now, first of all, use the curly brackets over here. Okay, and let's now do something that we are familiar with. We are going to have a comma separated list. So question mark, question mark, question mark, and question mark. I'm going to replace the question mark over here by something else, but let's understand the big picture. You can think about this particular array, just the curly brackets over here. We are basically specifying the top level first dimension of the array. You can think about this part here is correspond to this particular first dimension. And the second, and every slot of that is just going to be an array over here, an array. So that'll be the second dimension. For every question mark, you can simply replace it by just another array. And what should be the type of that particular second dimension array? And it depends on what the type it is, which is integer. Okay, so let's try. How can I simply replace the question mark by, for example, I can simply copy this particular one-dimensional array, which we understood from before. I can simply replace this one by that. Okay, and then let me do another one, and then we'll review. 1, 2, and also 3, and then 4. And I can change the value for sure. Let's say 5, 6, 7, 8, and also 9, 10, 11, and 12. Let me just have that. Okay. So let's now review this quickly. Overall, you can see it is a two-dimensional array. The first dimension is simply starting from this curly brackets over here, ending with this particular square brackets, and this will be the first array in the second dimension. This will be the second array in the second dimension. This will be the third array in the second dimension. Think another way. This first second dimension array is stored at index 0 of the first dimension array. And this one here is stored at index 1 of the first dimension array. And this third array is stored at index 2 of the first dimension array. It might sound a little bit confusing, but once we visualize it, you will understand what I just described is exactly what I'm going to draw to show you. Another way to make it more understandable is you can use some new line and indentation. Let me just try to show you. I can simply hit a new line over here, and then so this will be the first row and second row and also the third row over here. Okay, like that. And then I can also maybe try to align the elements over here better. Okay, and then like that. All right, so this will be the second dimension array. This will be another second dimension. This will be another second dimension. And overall, we got a first dimension over here, just one. Okay. All right, so that's about the syntax for declaring the second dimension array. You can think about it's really like a table that you will see in the Excel spreadsheets, or the distances table that we saw previously. But let's now try to visualize it quickly. Okay, you can see this is the list 2 that we just declared in the Eclipse, and let's now understand it again. Okay, let's now start from the first dimension here. You can think about this part over here is the first dimension. Okay, so now let's write it down. So this will be the first dimension. And in the visualizer, you can see that one corresponds to basically starting from here and also ending over here. So that's the first dimension. There's only one single variable that will be storing the entire array, right? And first dimension is like a top level. You can think about as well. It's more like a top level. Okay. What about the second instance of the square brackets? It will be the second dimension array. So you can think about this part over here, the pink one over here. So that will be the second dimension. Okay, so let me put it here. So that will be the second dimension. Okay, and in this case we got we got 3 arrays in the second dimension. So you can see this will be the first one, the second one, and also the third one. Okay, and just say a little bit more before I draw some diagram to show you. You can think about this first array is stored at index 0 of the first dimension array, index 1 and also index 2. So how do we visualize this? So there are 2 ways to visualize this. I will try to show you both, but I will recommend the latter one as I will show. Okay, let's now draw the first dimension. You can see the blue one over here. So you can think about it's really like a list 2. List 2 is really pointing to an array of size 1, 2, 3. So you can see list 2 is just like a normal array that we have seen previously. And that one's 0, 1, and 2. Right? And now what should be the type for every element in the list2 array, every index over here. According to the declaration, you can see it's going to be just another array of type integer for every element, right? So that means for index 0 of the first dimension array over here, you can see the index 0 of the first dimension array is going to store the starting address of this particular array in the second dimension. Let's visualize it. So what's going to happen is it's going to point to the starting address of another array over here of size 4. So we got 4 slots over here. And then, so we got indices 0, 1, 2, and 3, right? Let me just copy this particular structure over here. We're going to need it, okay, for the other indices. What about, I will fill in the context in just a moment. You can see here, what about at index 1 of the first dimension array? It's going to store the starting address of just another array, right? So let's now do that. So I'm just going to paste the structure over here, okay? Let me just get rid of this, so I don't need that. Okay, so there's going to be another array over here. I'll put it here. Okay, so this is the first way to visualize it. You might find that it may not be so easy for you to draw, but I'll show you another way that's much easier to draw. Let's get there a little bit later. So for index 1, you can see index 1 is going to point to this particular, the starting address of this particular array of size 4. So that's why we should really, so this will point to the starting address of this particular array. At index 2 will also point to this array of size 4. Okay. In principle, in general, you may decide to have arrays of different length in the second dimension, but we wouldn't really discuss this week. But we'll talk about it maybe next week when we try to explore deeper about defining utility methods on two-dimensional array. That's something we'll do. But for now, you can simply just see the special case where every array in the second dimension, they simply have equal length. Okay, that's something we can just assume just for this week. All right, let's now fill in the contents over here. You can see this is, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, let's now introduce about indexing right away. So you'll be very intuitive. Okay, so let's say I want to do the following. I want to get access to, if I simply say list2, versus if I say list2 at index 1, versus if I say list2, I can also say 1 and then another square brackets, maybe I would say 2. Let's see what the difference is between these three expressions. So the first one, if I say list2 over here, so list2 is simply just talking about this particular array, and then it's simply pointing to the starting address, right? What about this one? If I say list2 at index 1, so that means I got list2, which stores the starting address of this particular array, and I talk about index 1. So index 1 is really pointing to the starting address of this particular array, right? So this is what this expression means. Then finally, if I say list2, 1, and 2, I really try to go navigate between the dimensions. So if I say list2, first of all, list2 is going to navigate me to the starting point of this particular array. And then I will go to 1. Index 1 is over here. That one there is going to get me to this particular array, the starting point. And then I want to go to index 2 of that, which will be over here. So this will be, so both are actually valid. You can think about here, the second one here, this is for you to retrieve the second row. And this will be to retrieve the intersection of second row and also third column. It might be quite difficult for you to actually see, to really convince yourself that the pointer over here is really the second row, and over here is really the third column. So that's why I said the first visualization is actually not the way to go. I would actually recommend you try the second one, which I'm going to do now. But at least you should see This might be very intuitive to visualize based on what you have understood from the previous tutorial videos and lectures, right? You can see here, this will be the first dimension of the array. And then you can also get access to the second dimension by using some indexing, right? So that's basically the point. What about the second way of visualizing the two-dimensional array? In this case, I would suggest we try to actually play with the orientation of the first dimension. Let's try that, okay? So what I will do is I'm going to put it here. Let's say list 2. So list 2 is going to point to the starting address of the first dimension. And again, the first dimension is going to be of this particular array of size 3. So 1, 2, and 3. So I'll draw that vertically, like that. So you can think about this one here is going to be 1, and 2, and 3. So indices will be 0, 1, and 2. So now compare and contrast. I'm drawing this vertically versus horizontally. Semantically speaking, they're equivalents. So just a matter of preference. But I would say this one will turn out to be much more superior in terms of helping you understand. What about the second dimension? For the second dimension, each one of them is each one of the arrays in the second dimension is going to be, for example, index 0 is going to point to the starting address of another array. And also index 1 stores the starting address of another array, and etc. Why don't we try that? So you can see index 0 points to the starting address of another array of size 4. Okay, so let me 1, 2, and also 3. So 0, 1, 2, and 3. And let me just copy the structure over here. And in this case, we simply just got the same structure for every array in the second dimension. Okay, so this will be the second one, and this will be the third one. Okay, let's now try to interpret the notation again. What about this one here? When I just say list 2, it's going to be basically this. So list 2 is just going to point to the it stores the starting address of the array. So when I say list 2, I really talk about the starting point of this particular array. Okay, and what about when I say list 2 at index 1? So when I say list 2 at index 1, so let's try this. So list 2 point basically visually speaking pointing to the starting point of this array, and I want to go to index 1. Index 1 is basically here. So that means it's really pointing to the starting of this particular array. And then what if I want to say list 2 and then go to 1, which is already here, and then I want to go further to the second, the index 2. Index 2 will be over here. So that's really referring to this particular elements, right? And oh, by the way, the contents I can also fill it in. It will just be 1, 2, 3, 4 corresponding to this particular array, and also 5, 6, 7, 8, 9, 10, 11, and 12. So now it will make much more sense. You can see list 2, 1 is really referring to this. So this is really the second row, right? You can see first row, second row, and third row. And when I say list 2, 1, 2, right? I'm really saying list 2 and then 1 and then 2. So I'm really talking about the intersection of the second row and also the third column. So that's really the intersection. So that's why I said this particular way of visualizing your two-dimensional array, where the first dimension is really presented vertically. So I think that'll be much better for your understanding. Okay, so that's why the first dimension is really specifying the rows: row 1, row 2, and row 3. And the second dimension is really about columns: column 1, 2, column 3, column 4, etc. All right, so that's about how you can visualize the two-dimensional arrays, and also how you can get access to individual elements. Hopefully that makes sense to you. Let's now move back to Eclipse, and I'd like to show you one more interesting alternative to so list 2, you simply just list row number 1 over here, row number 1, row number 2, and also row number 3 explicitly for each row, right? There's another way to do this, which would be quite conceivable, but you may not have thought about it. Let me show it to you. Let me just rename this one-dimensional array as maybe row 1 over here. Okay, let me just create another 2 rows. Each individual row is just one-dimensional array. Okay, let me say this, row 2 and row 3. So I'm going to say row number 2, row number 3, and then I would say 5, 6, 7, and 8. We got 9, 10, 11, and 12. Let me just align the commas over here to make sure it's slightly predefined over here. All right, so that's my 3 rows. And I would suggest this. Let me cut this, okay? And then, so this will be the final 2 versions I would like you to keep. Let's say list 2A, version number A, okay? Let's have another one. Let's say version B, okay? Again, we got 2 dimensions over here. So the first dimension is here, and then every slot in the first dimension is going to store just another array, which itself is a 1-dimensional array. And every slot in the second dimension, well, every slot for in each of the arrays in the second dimension, they are going to store in their slots just integer over here. And then I can say list 2-dimension version B. So now I can simply say this. So let me start with the curly brackets over here, and then I can do this. And now I can say row 1, row 2, row 3. Let me put it here. Okay, you can see now I can refer to row 1 and also row 2 and also row 3. So this will also work. You can see I'm just being a little bit more flexible. So I'm just referring to the variable. You can see, you can think about row 1 over here, simply store the address of just another 1-dimensional array, pretty much like here. You can think about over here. So this particular slot stores the starting address of just another 1-dimensional array. So it corresponds to exactly how we visualize it. And you should really, from now on, stick to this particular way of visualizing the 2-dimensional array. So that's going to make your tracing, I think, easier.